In this video, we want to review U-Substitution from Calculus 1 in preparation for Calculus 2. The best way to do that is to remind ourselves where U-Substitution comes from, what it's doing. In order to do that, we need to start back with the chain rule. So the chain rule applies when I have a composition of functions. If I have one function inside of another, and I want to take the derivative. So I have an inside function, and I have an outside function that inside function was plugged into. The chain rule says that the derivative is the derivative of the outside function, keeping the inside function the same. Then at the end of that, you multiply by the derivative of the inside function. So that's what the chain rule says. Let's do 3 quick examples to remember how that works, and then we can remind ourselves about substitution. So here I have sine x cubed minus 2. So the x cubed minus 2 is my inside function because it is plugged into the outside sine function. So my derivative, I take the derivative of the outside function. The derivative of sine is cosine. Keep the inside function the same. So that's x cubed minus 2. Then multiply by the derivative of the inside function, which is 3x squared. Some people prefer to put the 3x squared in front of the cosine. Doesn't matter. Okay, let's look at the next one. This one is a little harder to see what's the inside, what's the outside, unless we rewrite it. So this function, 1/5 sine to the 5th x, is the same thing as saying 1/5 times sine of x that to the 5th. So the 1/5 is off by itself, but that whole sine of x is to the 5th power. Now I can see that I have an inside function, which is sine, and an outside function, which is that 5th power, because sine was plugged in to the something to the 5th function. Okay, so our derivative, we're going to have 1/5 times, use the power rule on the outside function, 5 inside function to the 4th. Remember, inside function stays the same to give me sine of x. Then you multiply it by its derivative, cosine x. We can rewrite this a little cleaner as sine to the 4th x times cosine x. Okay, one more and then we'll get to substitution. So here I have a square root of the whole 1 plus square root x. So that 1 plus square root x is my inside because that is plugged in to the square root x, which is my outside function. All right. Remember, a square root is a 1/2 power. In fact, I can write that in for you. So that's what we're going to take our derivative on. That means I need to use the power rule. So outside function gives me 1/2 times the inside, which is going to stay the same, to the negative 1/2 power. That inside is 1 plus x to the 1/2. Now, derivative of the inside is 1/2 x to the negative 1/2. We can clean this up and write this a lot nicer. So it takes a little bit of algebra, but it's not too terrible to get that this is 1/4 square root x times the square root 1 plus square root x. All right, so that's the chain rule. The point of substitution is I want to reverse the chain rule. So I want to be able to look at something like sine to the 4th cosine x and get back to the 1/5 sine x. Something like this craziness here, 1/4 root x square root 1 plus root x, and get back to that original function. That's the point of U-Substitution. So the way we do that is we have to pick out what the original inside was, okay, and work from there. So let's do some examples of that. Okay, so here I have an integral, cosine cubed 2x sine 2x. So I need to figure out what I think the original inside was, and I'm going to call it u. Then when I take his derivative, it should appear somewhere in this integral. Okay, because the chain rule said at the end I multiplied by the derivative, so the derivative should appear somewhere there. So I look here, I see a cosine and a sine. Say, well, I know cosine has a derivative that involves a sine, so maybe that will work. So let u be cosine 2x. Now my du, because of the chain rule, I'm going to get a negative 2 sine 2x. If you don't see that, go back and study the chain rule a little bit, because you've forgotten some chain rule. Okay, so I look up here, my du, I have a sine 2x that matches, but I don't have the negative 2. That means it canceled away. So the way we fix that, I'm going to multiply by 1 in a clever form, negative 2 over negative 2. The top negative 2, the numerator, is going to get used because negative 2 sine 2x dx is the exact same thing as du, so that makes a du. The bottom negative 2 in that denominator, he's still going to be there when I rewrite my integral with the substitution. Okay, so I get my new integral. I have a negative 1/2 out front. That's that negative 2 in the denominator that didn't get used. I have an integral. Cosine is the same thing as u, so that cosine cubed is u cubed, and everything else was part of my du from when I did the chain rule. Now this is in a form I can integrate. All right, reverse power rule, add 1 to the exponent, divide by that new exponent, put a plus c. So we're getting negative u to the 4th over 8 plus c. We're not quite done. I started with x's. I need to end with x's. So this equals negative, what was u? U was cosine 2x. So cosine 4th 2x over 8 plus c. Okay, let's do one more refresher on how U-substitution works. So here I have a messy integral, and I want to figure out if I can find an inside whose derivative already appears there, because I did chain rule, so his derivative should appear there somewhere. So I see this x to the 5th, and I know his derivative will have an x to the 4th. So that's promising. So I'm going to take u to equal 1 plus x to the 5th, because that 1's derivative will just be 0. So du is 5x to the 4th dx. All right, I have an x to the 4th. I do not have a 5, but that's okay. I'm going to multiply by 1 in a clever form. And then I can have 5x to the 4th dx, which I know is equivalent to du. All right. So let's start rewriting this. I'm leaving off the limits of integration for a second. We'll come back to those. But my whole numerator got used in du. My denominator, the 1 plus x to the 5th, becomes u, so I have u squared. And I have that 5 in the denominator that I didn't use, so I'm going to pull the 1/5 out to the front using my constant multiple rule. Okay, so we're almost done, but this integral is a little different from the first, right? Because I have actual endpoints. It's a definite integral. So this actually is easier with U-substitution. I just need to convert my endpoints. So take your u. My lower endpoint is for x equals 0. Well, that means u is 1 plus 0 to the 5th, because u is 1 plus x to the 5th, so u is 1. So my new lower endpoint is 1. My upper endpoint is x equal 2, so that means u equals 1 plus 2 to the 5th, so my new upper endpoint is 33. All right. Now we can keep going. So to integrate this, I need to rewrite that u with a negative exponent, so I can use my reverse power rule. And my reverse power rule, again, add 1 to the exponent, divide by that new exponent. Alright, so you do a little bit of algebra, you plug in those endpoints, and you will get 1/5 times negative 1/33 plus 1. So those are two examples of U-substitution. In the next video, I'm just going to do 4 more practice problems. It's a good idea for you to get to work on them first. If you want to see them, if I can get this thing to move. There you go. If you want to see them so you can practice first, there they are. So go ahead, feel free to practice those first, then go on to the next video, and I will work through them all.